G'day, I'm Lachlan Campbell from ProAgni, and I'd like to share with you some recent research on rumen pH management. Inducting animals onto grain sets up the rumen for the entire feeding period, but it's also the riskiest. Issues during this period are costly and compounding. Why? Because induction destabilises the rumen environment, including pH, and places a metabolic burden on the animal. Get it wrong and you reduce performance, productivity, increase welfare issues, and increase animals' time on feed. The more stable the pH and fermentation pattern, the more money for the farmer. What you're about to see is an animation of the results from a trial at the University of New England conducted by Professor Roger Hegarty in 2019. The trial tested the effectiveness of ProTect, our antibiotic-free standalone vitamin and mineral premix, against a control group of cattle fed a medicated premix including ionophores. This is the University of New England's data and statistical analysis. A total of 10 Angus steers, 5 in each group, were each equipped with an interruminal pH bolus used to capture the raw data. UNE plotted this time series to track the difference in rumen pH variability. 10-minute readings 24 hours a day for 36 days were taken during 4 successive feeding regimes, each with an increasing percentage of barley. The analysis compared more than 51,000 unique data points highlighting fluctuations in rumen pH, animal circadian rhythms, and inter-animal variability. The tiny columns represent the range of data between the 25th and 75th percentiles, and the dots represent the outliers. The longer the columns and further away the dots, the greater the variability between the 5 animals in that group. Let's compare the changes in pH over time and step inside the rumen to observe what every feedlot manager sees during grain induction. The top graph shows the 5 cattle fed the ProTect diet, and the bottom graph shows the cattle fed with the standard rumen modifier. From days 1 through to 7, the steers are on a starter ration with 45% barley. And you can see how much the pH variability stands out. When pH is too low or too high, moving outside the optimal range, animal performance suffers. When pH drops below 5.5, which is clinical acidosis, then the issues become more serious. The large movement of rumen pH for both groups demonstrates the challenge of maintaining pH within that optimal range. On day 8, the barley percentage steps up to 56%. Again, the greatest variation and the lowest pH can be seen in the 2 days following the change of diet. The higher the top into alkalosis, the greater the fall into acidosis, and the longer the animal stays there. The next step up in grain is at day 15, where the diet now contains 67% barley. We can see the ProTect range of banding is tighter and the rumen variability is nowhere near as great. So what are the takeouts of the trial? ProTect fed livestock recorded a more stable rumen pH compared to the control group fed the premix containing ionophores. You can't see subclinical acidosis building inside the animal, and when symptoms show, it's often too late. The ProTect rumen pH was within the optimal range for a significantly higher proportion of the time, increasing digestive efficiency. Fluctuations in rumen pH outside the optimal range increase the metabolic burden on the animal. Energy and nutrients meant for growth and production are used instead to manage homeostasis. Clinical acidosis turns up in your gross margin, often as dead animals, but subclinical acidosis turns up at the end of the year in your profit and loss. For further information on this trial and others, or to learn more about our antibiotic-free feeds and supplements, visit our website at proagni.com.